Hello and welcome to Basic Medical Sciences. In this video, we're going to talk about cholinergic receptors, right? So these are the receptors which use acetylcholine, right? There are two kinds. There is nicotinic receptors and muscarinic receptors. Nicotinic receptors can be further divided into those ones which are found on the nerves, right? So we can say NN, nicotinic for the nerves, and another one, nicotinic receptors found in muscles, right? So for the nerves, they are mainly found like first one, autonomic ganglia, right? What is a ganglia? A ganglia, a group of cell bodies in the peripheral nervous system. They are also found in the central nervous system, and the functions will be memory, analgesia, arousal, etc., like the general functions of the CNS, right? And in nicotinic receptors found in the muscles, right? So these ones will be found specifically skeletal muscles. Okay, right. So I'm not going to talk much about nicotinic receptors because like I'm going to show you like receptor pathways, like the mechanism, how those receptors work, right? So I will talk mainly about the muscarinic receptors, all right? So these ones, they are divided into 5, right? There is M1, M2, M3, M4, M5. Right. Muscarinic receptors are also known as G protein coupled receptors or 7-pass receptors because like they pass across the membrane like 7 times, right? So like I said, they are coupled with G proteins, right? So in general, there is G stimulatory, GQ, and G inhibitory, right? So G stimulatory, you find them like in adrenergic receptors, right? In muscarinic receptors, we only have GQ and G inhibitor, right? So here, for if you stimulate the GQ receptors, like there will be contraction, right? There will be contraction of smooth muscles. If you stimulate the G inhibitor, is inhibition, right? So there is an easy way to remember how this works, right? For example, for M1 is stimulatory, M2 inhibitor, M3 stimulatory, M4 inhibitor, M5 stimulator. But remember, this is not G stimulate. It's not about like the protein coupled to this receptor, G stimulatory. No, but I'm talking about action, like what happens, right? So for GQ, the smooth muscles will contract. So, let me show you like in detail the receptor pathways, right? What basically happens at cellular level. Right. So imagine this whole thing, right? This box is a cell, right? And this is a cell membrane, right? So embedded on the membrane, we have our G protein coupled receptors, right? The first one here is actually GQ, right? GQ. And this one is G inhibitor, right? G inhibitor. Right, so here is what happens. On GQ, I told you that here we are dealing with M1, M3, and M5. M1, M3, and M5. That's for GQ, right? Right, and the neurotransmitter we have here is acetylcholine. Acetylcholine. Right, so here is what happens. Originally, this GQ will be bounded to ADP, right? But when the neurotransmitter or acetylcholine attached to this, it will drop off the GDP, and it will pick up another molecule called GTP, right? GTP. Right, so this will activate this protein, right? So it will be activated, right? And upon activation, this will enhance, will stimulate an enzyme in the cell membrane called phospholipase C, right? Phospholipase C, right? So it will be stimulated, right? Okay, so there is a molecule called PIP2, right? So this is short for phosphatidylinositol diphosphate, or phosphatidylinositol diphosphate, right? So this molecule will be cleaved by this enzyme called phospholipase C, right? So this will give us two things, right? So the first one, what we'll get here is IP3, right? IP3 is inositol triphosphate, and the other thing which we'll get here is DAG, or diacylglyceride, right? All right, so what will happen here is, like, here you are looking at, because it's a smooth muscle, so there is a sarcoplasmic reticulum, which is a bank for calcium, right? So this one will stimulate the sarcoplasmic reticulum to release calcium, right? So from there, if you still remember, there is another molecule called calmodulin, right? Calmodulin. Right. So calmodulin and calcium will combine to form calcium calmodulin complex. Some people, they just say calcium calmodulin kinase, right? Calcium calmodulin kinase. Right, that's the first thing, right? That's the first thing. Let's underline it here. Right, what about diacylglyceride, or DAG? Right, this one will stimulate another enzyme. This enzyme is called phosphokinase C, right? Phosphokinase C, right? It's the second thing which we need to underline here, because these are the main important molecules which we use for different purposes. For example, this is what happens. These two things have the ability to phosphorylate different proteins, metabolic enzymes, by phosphorylating them, right? So we can say they phosphorylate proteins, or simply metabolic enzymes. Right. And also they can also phosphorylate, for example, like even calcium channels on the cell membranes, right? So here just represented this one as a calcium channel, right? This one. So if they phosphorylate, they put phosphates around here, the calcium channel will be opened, right? And calcium will enter into the cell. Right, for what? For muscle contraction, right? Because we are saying this is smooth muscle, right? So it's for muscle contraction, right? This one is another pathway which I just told you for phosphorylation of enzymes, but you just need to know calcium is for smooth muscle contraction, right? So that was about the GQ pathway. Now let's talk about G inhibitor, right? So as I indicated here, G inhibitor is actually 3 subunits, right? It is alpha, beta, and delta, right? So Okay, I didn't indicate here. This one, because the first one on GQ is M1, M3, M5. So obviously here it will be what? M2 and M4. Right, M2 and M4. And again, the neurotransmitter here, we have acetylcholine, right? So if it attaches to this receptor, the G protein here will be cleaved into two groups, right? So the first subunit is this alpha, right? This alpha subunit, okay. And the other one is like this beta and delta, right? So let me just put it this way. This one is your delta and this one is your beta. Okay, in full is beta 1, delta 1, alpha 1, right? Okay, so in general, this what we are looking at here is an enzyme. This one is very important. We will talk about it again and again, right? So this enzyme is called adenylate cyclase, right? It's responsible for conversion of what? ATP to cyclic AMP. ATP to cyclic AMP, right? So what will happen is like this subunit will this alpha subunit will inhibit this enzyme, right? So if it inhibits this enzyme, it means like there will be less cyclic AMP in the cell, right? So like reactions which are like phosphorylated by this cyclic AMP, they will be like decreased, right? Because there is low cyclic AMP. Particularly the enzyme here, like which is normally stimulated by cyclic AMP. Let me just put it here, PKA, right? So it won't be activated, right? So let's just say it will be something like inhibited, but it's not inhibited really. It's just like it's not stimulated that much because there is low cyclic AMP, right? What about this beta and delta? Right, so this is what happens to this, right? So you know, like on this cell we have like potassium channels, right? So potassium channels will be activated by this subunit, right? So if they are activated, you should know that potassium it usually goes out of the cell, right? All right, so let me give you just an overview, right? Because I told you like the M1, M4, and M5 are mainly found in central nervous system. M2, they are found in the heart. M3, smooth muscles and exocrine glands. And nicotinic receptors, here I just want to talk about those ones found on skeletal muscles, right? So here is what happens. If you stimulate the M1, M4, and M5 in the CNS, the effect, right? Okay. The most important thing which I want to tell you is like the drugs which stimulate these cholinergic receptors are called cholinomimetics or parasympathomimetics, right? So if those drugs stimulate, for example, M1, M4, M5 in the central nervous system, this will influence neurologic functions or like memory, etc. If you stimulate the M2 receptors in the heart, this will decrease heart rate and atrial contractility, right? And this will in turn slow down the AV conduction, which can cause AV block, right? So remember, like in the heart, these M2 receptors are found in conducting cells, right? Not contractile cells, but in conducting cells, right? The next one, if you stimulate the M3 in smooth muscles, right, this will have like different actions in different organs, like visceral organs, right? For example, in gastrointestinal tract, this will stimulate or increase intestinal peristalsis. In the genitourinary tract, this will increase bladder contraction. Like, how does this happen? There is increased detrusor muscle tone and relaxation of internal urethral sphincter. So this will allow the person to pee, right? Okay, and in the airway, we mainly talk about bronchoconstriction. The person is relaxed, right? You don't need to breathe so hard. So there is bronchoconstriction, and also there is increased bronchial secretions, right? Next organ in the eye, right? So in the eye, what happens is like there is meiosis, like that's the narrowing of pupil and accommodation. And the other thing that happens there is that the lens will become globular for what, for near vision, right? And this M3 can also be found in blood vessels. This one will be for vasodilation, right? Okay, the next one, the next organ or the next tissue, exocrine glands, right? So if you stimulate the M3 receptors in exocrine glands, they will increase the secretions. For example, gastric acid, where if we are talking about the in the stomach, and also sweat glands, right? If you stimulate the nicotinic receptors in the skeletal muscles, this will increase muscle contraction and muscle tone, right? Thank you so much. If you like this video, please make sure you subscribe so that you won't miss any of our latest videos.